So in this problem, what we have to do is we have to find the natural frequency of this system. So we have to find the frequency of this system. So how we are going to do this is basically by finding the equivalent spring stiffness of this system. So here we can see that we have a spring with spring constant K1, and this spring is having spring constant K2, and it has also a mass M attached to it. And this thing you can see over here is the pulley here. Okay, so how we can do this is basically we already know that what is the equation for frequency. Frequency is nothing but 1 divided by 2 pi root over k equivalent divided by the mass that is attached. So here we can already see that we have two springs. Okay, so how we are going to be dealing with that, let's take a very close look at this. So at first we need to find the value of Ke here, right? If we can find the value of Ke, then we can easily input that value of Ke in this equation, and we can find the frequency of our mass pulley spring system. Here, consider that I am applying P amount of force here, okay? I'm applying P force, okay? I'm applying P force here in the K2 spring. So if I'm applying P force, what will happen here? We already know what is the spring force. Spring force P is equal to K into X. Here, what is the spring constant? That is K2. So K2 into X. X2. X2 is the displacement of this K2 spring, I can say. This spring having displacement K2, displacement X2. All right. So we have already been able to found that what is the force we have applied here. P is the force applied. Okay, so P is the force applied here. We can say that P is the force applied, and due to this force, what is the equation here? Equation for this spring, that is K2 into X2. Okay, K2 is the spring constant for this spring, and X2 is the displacement of this spring. And what will happen here, this is very interesting. What is going to happen here, we can see that due to this force, P force, this P force will become P by 2 force here. P by 2 force. P by 2 is equal to K1 into X1, where K1 is the spring constant of this spring, and X1 is the displacement of this spring. Okay, so this is the equation that we can obtain from here, and this is the equation we obtain from here for the K2 spring, and this is the equation for the K1 spring. There is another thing. See, we have already been able to find what are the equations that we already found. Let us write. We have found that P is equal to K1 into X1, and sorry, P by 2 is equal to K1 into X1, right? P by 2 is equal to K1 into X1, and P is equal to what? P is equal to K2 into X2. From here, I can very easily find from here X1 is equal to nothing but P divided by 2K1, and from here I can find X2 is equal to P divided by K2. So now there is another thing that we need to take into our consideration is this, that what is the displacement of this system? That I say that the displacement is xe. If okay, so as we have already applied the force P here, so due to that P force, we are getting x2 as displacement here, and here the displacement will be x1 by 2. The displacement is also going to be half here. Okay, so now as you can see that I have written x1 by 2 plus x2. This is the equivalent displacement, I can say in one word. So here you can see the value of x1, you can already put the value of x1 from here. The value of x1 is P divided by 2k1. So P divided by 2k1, already 2k1 and already 2 is here, so we can multiply them, and we can write 2 into 2, that is 4 into k1, plus x2, the value of x2 is P divided by k2. So now if I do, so this is my xe, value of the displacement, right? The equivalent displacement. So what is going to be the equivalent stiffness? Due to the force applied P, I have got the ke into xe. So from here I can get the value of ke. What is the value of ke? Ke will become P divided by xe, and we have already found the value of xe, that is P divided by 4k1 plus P divided by k2. So this is the value, and I can do some more calculation here. Here it can become 1, and k2 plus 4k1 divided by 4k1 k2. So from here I can find 4k1 k2 divided by k2 plus 4k1. So I've got the equivalent stiffness of this spring. Okay, I have already got the equivalent stiffness. So now what I can do is I have already told that we need the value frequency. So what is the frequency? Frequency is equal to 1 by 2 pi root over ke divided by m. So here you can see 1 by 2 pi root over the value of ke is here. The value of ke is 4k1 k2 over uh, k2 plus 4k1 and the mass. So in hertz. So this is our answer of the system. So